Good afternoon. So this is the intro to my trigonometry this year. Okay, so it's 1.2 angle relationship and similar triangles. Now, we're going to go through and do this step by step. You guys are going to follow along with your notes, right? For those of you with the at-home version of the game, you guys go ahead and play along. All right. So, vertical angles. Now, for you guys, vertical angles, what shape do they make? X. Very good. They make an X. Okay, so whenever you see that X, you should automatically be throwing out vertical angles. Okay, you should automatically. Here's an X. Now, opposite sides of vertical angles are going to be congruent. The word congruent, what does the word congruent mean? Equal. Thank you. Having the same measure. They're going to be equal to each other for what I'm talking about here. Okay, so if I'm looking at this, these two in red are going to be equal to each other, and then up and down in blue are going to be equal to each other also. There's an issue with this one right here. Watch. So now, that guy right there, what's the issue with this right here? What's wrong with the markings?
They're off.
Why?
It's smaller.
Nope. Someone help them out. What's wrong with the markings? They're not equal to each other, right? So, are all four of these equal? No. Okay, so now this one has to have a second one, right? What was that? Okay, so right here, there we go. So right here, double marks, right? Double marks say that these two are equal to each other, and the single mark says those two are equal to each other. Okay, so I know you just fixed that on your notes right now too, right? Yes. Good. All right, parallel lines are lines that line the same plane, do not intersect. Okay, when a line Q intersects two parallel lines, it is called a transversal. And because of that transversal, I'm going to have certain angles that are going to be congruent to each other. And this only works when they are parallel. Okay, so let's take a look. So I'm going to go with this one right here. 1. Which one is that going to be congruent to? 5. Now. Okay, someone tell me the name for those. The name of that pair.
Alternate exterior angles.
Alternate interior angles.
Come on now.
Interior and interior angle.
You're close. We had a special name for this. Got a bag of Takis right here for this. Okay, so now, okay, time up. They're corresponding. If you guys remember, it is inside, outside, same side of the transversal, corresponding. So those are corresponding there. So now, those are not the only ones that are congruent to each other right there. What else do I have that's congruent to angle 1? 4. Why is 4?
Because it's directly across.
And that is a what type of angle?
Vertical angle.
Vertical angle. Very good. So 8 goes the same thing. What about 1 and 8? What did I call that one? 1 and 8 are what? Very good. Alternate exterior angles. Good job. Okay. So now, how about 2? What is 2 going to be congruent to? 3. Okay. And 7 and 6, right? Okay. A lot of congruency here, right? Okay, good. Now, right here, alternate interior angles. Okay, they have right here, alternate interior angles. They should be 4 and 5 here, right? Also, and this goes by from the previous one, from the previous diagram. Okay, right here, the angle measures are equal. So when I'm solving this, I'm solving them when they're equal to each other. Okay, they are going to be equal to each other. It's very good. Alternate exterior angles, again, are congruent. So, and I'm solving it, I set them equal to each other. Interior angles on the same side of the transversal. This is called consecutive interior. Consecutive interior. It says they add up to 180. So what I would do on this one, I'm going to solve it differently, right? They're not equal. I would say basically A plus B equals 180. That means both of those together, when I combine like terms, will add up to 180. Jess?
Yeah.
Okay, I know you guys are taking notes here, right? Filling in the blanks. Corresponding angles. There's my inside, outside, same side right here. Angle measures are equal. So when I'm solving that, what do I put there? Equal, because there's an equal between them. Find the measures of 1, 2, 3, 4, given that lines M and N are parallel. Okay? So, first things first. I need to have a relation here. There's going to be a relation here. So I need to know, are they going to be supplementary, adding up to 180, or they're going to be equal? So I have 1 and 4 here. Those are going to be what? Equal, because they're alternate x here, right? Say Jess.
Yes.
Very good. All right, set them equal to each other. So I'm going to go 3x plus 2 equals minus 40. Very good. Okay, start by subtracting or combining like to whichever side you want, actually. So I'm going to move it to the right. I'm going to move the variable to the right. Why would I do that? It's going to be a positive over here, right? If I subtract the x's to the left, it'd be a negative, right? It's just one step. I'm trying to save myself a little work. So subtract 3x from both sides. Right? Yes. Okay, so if I'm subtracting this from this side, where's the 40 go? To the left, right? To the left. So what would I do to the 40? Very good. Add 40. Let's do that. What happens to my 3x's? That goes 0, right? So over here I'm left with equals. Now, the 40s go away, right? So how many x's do I have? I have 2x. Very good. Divide by 2. Answer is 21. 21. Now, is that the answer? Say no. That's the value of x. Did it say solve for x?
No.
Nope, it did not. It did not say solve for the value of x. It said find the value of the angle, the measure of the angle. So you guys got to think about that when you're reading this. So what he said right there is do what? Plug it in. So let's go ahead and plug it in. So 3 times 21. 63. 65. So now, do I have to plug it in again over here? No. These are going to be equal, right? So I say that this one's going to be 65. What else do I know? 3, right? 3 is going to be 65. Now, 1 and 2 are what type of angles? They're supplementary. Very good. They're supplementary, so they add up to 180. So if they add up to 180, how would I find the missing here?
180 minus 65.
Very good. So it's actually angle 2 plus 65 equals 180. And so I'm just showing all the steps. You got it right, though. Okay? So subtract 65 from both sides. Angle 2 is 115. Now, do not forget to label your units. Jess.
Yes.
Very good. How you guys feel about this?
No, we're actually learning something, not getting better.
Hey, listen, I got you, fam. Okay? All right.
She was teaching a completely different thing.
She wasn't even teaching.
She wasn't even teaching.
Hey, chill. Okay? We're not here to complain, all right? I got you now. Next problem. Angle 4 has measure. Wait, hold on, crap. Is that the same problem again?
Yeah.
Dang it, I just copied it twice. Sorry. Hey, look, we did all that in the first one. All right, now, all 3 angles in a triangle add up to 180. So, a triangle has how many angles? 3. It's a triangle. How many sides does it have? 3. Okay, I'm just testing you here, all right? Okay, triangle has 3 angles. All 3 of them together must add up to 180. That's very good. You'll need that. So, I know that these 3 together have to add up to? So to do that, I would do 48, 61 plus equals. There we go, right? You can do it. It's all up to you. You could. All right, add them together. So, come on, you can do it. 109. Thank you. You got this thing on your shoulders that actually calculates 109 plus x equals 180. What do I do from her? Subtract 109. X is 71 degrees. So my third missing angle came out to be 71 degrees. Yep, you could plug it back in, check to see if it works, right? Okay, types of triangles. Okay, if all the angles are less than 90, it is going to be acute. Now think of it like this. If it's small, it's cute. Right? If it's small, it's cute. So if all of them are less than 90, all of the angles are less than 90, it's acute. Now, right triangle. If one of them is 90, it will be a right. Is it possible to have two right angles in a triangle? No, because you can't have two 90s, right? Because you have to have three angles to be a triangle. So if I had two 90s, it's just a box that opens up, right? Okay, so obtuse means it has to have one angle that's greater than 90. But if you look at these ones over here, are those ones less than 90? Yeah, same thing goes with my right. These ones are less than 90. But it's the one that's actually right here that's going to get us. Jess?
So it's just that if more than likely they're gonna have that little square.
If it's a right. If it's a right, okay? Or there'll be something telling you like, hey, this is a right angle. Jess? Okay. All right, types of triangles. All sides equal, it is a equilateral. Two sides equal, it is isosceles. No sides, it's a scaling. It's in your notes. You got this. Okay. Our triangle similar to corresponding must have same measure, corresponding side proportional. Okay. All right, so these are similar triangles. Okay, you guys did this back in geometry. Trust me, I had some of you people in geometry. You did this. Now, okay, if they are similar to each other, that means it's the same shape but different size. Same shape but different size. Don't you pop that again. Okay, so this is 45, that's 45. This is 31, that is. How else could I tell if I didn't already have, know that it's lined up like that? The lines, the tick marks right here in the angles, right? This has 3 arcs, and that one has 3 arcs, right? So that means that that one goes with that one anyway, right? So that one's 31. So what is that angle C going to be? Bam. Given a triangle ABC and triangle DEF are similar, find the lengths of the unknown side of the triangle. Now, so this one is my special type of math. Okay, my special type of math. You'll find out here in a second. So, which corresponding sides do I know? I should have a pair that I know. Okay, so this one right here, right? So I have the 16 and the 8, right? Those two go together, don't they? Yes, they do. So I'm going to start with that. Always start with what you know. Start with what you know. If I'm starting with 16 and I'm starting with 8, so I go 16 over 8 equals. Now, find the lengths of the missing ones. What do you want to find first? EF or DF? EF. So you want to find this one right here, right? So, since 16 was on top of this fraction right here, what do you think should go on top over here? 32. And whatever EF will be. Okay, if you want to put in an X and Y, We can do that too. X, AA. And so that one's an X, right? Yes? Okay, so cross products, 16x equals 32 times A. That is going to be 256. Divide both sides by 16. X is 16. Yes? Okay, thank you. All right, we're going to do Y now because I said so. Ready? How am I setting this up? Come on, class, pay attention. 16 over 8. Why'd you do 16 over 8? Very good, because you start with what you know. 16 over 8. Since I only have one other side to set up, how do I do that? Very good. 24 over y. 16y equals 2. 192. So 192? Yeah, 192. Yeah, 192. Divide both sides by 16. Y is 12. Patterns. Patterns. Look at the patterns. Look at the numbers. Look at the numbers that you know. The big one is how much bigger?
2 times.
Twice as big, right? Very good. That's what you guys need to look for also, right? Does that make it a whole lot easier? If you look at it, you see the patterns, I'm like, oh, hey, 8 and 16, the big one's twice as big. So I know that the small one has to be half as big. So half 32 gave me 16. Same thing goes over here. Half 24 should be 12. ¿Está muy fácil? All right. Is that the last example? Yep. Okay. All right. Workers here. Station need to measure the height of flagpole. They find that blah, 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 blah. Station, not, okay. So, instantaneous. So, this 99 feet long shadow. And this is, okay, 18 meters long, 10 meters high. Okay. Find the height of the flagpole. Now, this is again similar triangles. Okay? It just looks different. Now, that guy, what do you start off with?
What you know.
What do you know?
I know that the building, one of the sides is 18.
Okay, so now, how would I set up my fraction?
99 over 18.
Huh? I heard it. Very good, let's do it. 99 over 18. So you also could have set it up with 18 over 99, but you would just have to make sure you set up your second problem correctly also. So, since 99 is on top, what needs to go on top over here?
X or Y or whatever.
Okay, let's say W.
W only 10.
Right? So go through, do our math. Cross products, 99 times 10. 990 equals 18W. Divide by 18. Is that 55? No, can't be 55. Is it?
Yeah, it's 55.
Oh, 55. What are my units on this one right here, though? So the flagpole is in feet.
Meter long.
The flagpole is in what? Feet. Thank you. So pay close attention to your units. You notice these are meters, but the similarity, the ratio is going to be the same. As long as you have the same units on this side and same units on this. This was 99 feet and 55 feet. This is 18 meters and 10 meters. Does that make sense? So similar proportions right there, even though they're using different units of measurement. So you're okay there. So my W is 59 feet. Are we good? Okay. All right, so I think that's it. Yes, I'm going to leave off there. Don't forget, like and subscribe. Okay, hit that like, I don't know, what's that?
Shout out.
I know.